Good afternoon to everybody, and welcome to this demonstrative session for the use of APC environment for dealing with satellite and geospatial data application in the context of the urban environment monitoring, such as for application of soil consumption, green indicator, and so on. We will use today a framework that is released under a co-financed project by the European Union with the DYDAS project. DYDAS is the acronym for Dynamic Data Analytics Services. My presentation will show you at first some important points about this platform for HPC computation, and then we will move on to show you some an example of a practical use of the platform that is present in a beta version. So it is not fully available for users at this time, but will be released on the next month. So we are very closer to the release of the platform and to open these services to everyone. Okay, what is DYDAS? DYDAS is a project that involves the creation of a platform capable of handling a very large volume of dynamic data, and this will enable public sector and also high industry to benefit from this large-scale possibility of data analysis. In particular, with the DYDAS project, we promote the sharing and reuse of public data and also, of course, private data in a secure environment with dedicated framework for accessing, analyzing, and processing the data, as well as for showing the results with dedicated and dynamic customizable user interfaces. The platform that was developed for the DYDAS project will also act as an e-marketplace for data access and also for reselling and monetizing the results obtained by analyzing big data. In particular, we exploit big data technologies, machine learning and artificial intelligence, as well as some advanced services that I will briefly explain you today. This is the basic data flow management of the DYDAS system. The DYDAS gathered up data from a very heterogeneous ensemble of possible sources and make it possible to directly upload or to directly connect the data repository online, and by dedicated API which exploits the DYDAS and ATL processes, the data that you can employ in the system will be automatically harmonized and put it on a geospatial data lake, which solve the problem of dealing with so heterogeneous data sources, and which is connected directly with the HPC environment for operating custom modeling through statistical or machine learning algorithms such as artificial intelligence, for instance, as well as also for providing the facilities to operate custom algorithms and show the results over a dedicated user interface. A key factor of the HPC infrastructure is the possibility to perform very extensive data analytics in order to extract the information content and to benefit from the knowledge in the different field from various users that can share their data and their models through the platform in order to exploit the HPC processing power for providing readable data and results to the output API of the systems. Of course, there are many different key elements to be considered in order to implement such a complex infrastructure. And one of these, one important key element of the DYDAS infrastructure is the so-called geospatial data architecture, which is an ensemble of procedures which aimed to following the integration of the different data sets in a seamless, by a seamless approach, regardless of the different sources of data, as well as the different data formats and data contents. So this is just a few examples of different types of geospatial data that can be integrated in the DYDAS data lake by exploiting the functionalities of the geospatial data architectures. And this, of course, enable the implementation of, for instance, multi-temporal analysis performed by exploiting the temporal variation of the different type of geospatial data. Both public and private, from public and private sources. Another key element of the DYDAS is the presentation platform, which is also called a user experience platform. That is a complete customizable dashboard that can be exploited for presenting the results, for instance, of model runs, as well as for analyzing the information content of the different data sets once they were uploaded in the data lake. We will see some basic functionalities of the dashboard for the data presentation today. Of course, this type of project is mainly based on the role of open data for producing valuable information and computing new results by integrating different type of data. In this graphic, you can see the various categories of data that can be handled by means of the geospatial data architecture and the DYDAS data lake. Of course, a very important role is dedicated to the geospatial data in general and to the satellite imaging in particular, that can be integrated by exploiting the data, the geospatial data infrastructure, with other types of information, such as statistical one and social data, and also IoT data, for instance. The project also demonstrates its potentialities by developing 3 dedicated use cases, which are here indicated. In particular, we have 3 main use cases. The first one is dedicated to the monitoring of the mobility by employing IoT sensors. The second use case is dedicated to the energy balancing in terms of offers and demand of energy, and here we will employ a large ensemble of geospatial data, including satellite data. The third use case is dedicated to maritime observation, in particular to the forecasting of sea state variables such as waves and currents, and also this use case is related to the energy balancing, since it is possible to forecast also the amount of energy that can be extracted from the waves and current. And of course, in this project, we expecting an important role from the community of users and interested stakeholders, since the platform, as we already said, may provide an easy and seamless access to different kind of data that can be in a certain way mixed and manipulated in order to produce new value and new information by integrated data that in other cases are difficult to deal with, since are very heterogeneous, and also because it is required in general huge computational power to produce the expected results. So at this point of my presentation, before to move to the demonstration exercise with the DYDAS platform, I will require your attention over this first data user survey that can be completed by following this link. I can also share the link through the chat if I am able. Sorry, just maybe I have to show the link also in the last part of the presentation. Anyway, you can see here the link of the platform to the survey platform. Unfortunately, I'm not able to show you to put the link on the chat now. Anyway, I will come back to this at the end of my presentation, before to introduce the discussion of the outcomes. Oh, okay, maybe here we have this chart. Okay, thank you very much. So, okay. Today we will introduce example of an exercise that can be performed by exploiting the DYDAS platform, in particular by exploiting the basic functionalities of the DYDAS platform. In general, we have 2 different modalities of accessing the data. and producing the results. The first one is directly by using the DYDAS platform interface, and it is thinked for basic users that want to familiarize with the platform by exploiting the potentialities in the dealing with different type of data, and by testing also some basic to complex model directly through the platform interfaces. And this is the main concept that I will show you today. In a future webinar that we will communicate, for which we will communicate the scheduling on the DYDAS site, we will also show you the more complex interaction modalities, which is based on the directly uses of the HPC without the interaction with the user interface. Okay, today the example is regarding the developing of an unsupervised classification algorithm for change detection using the DYDAS platform. In this case, we will show the basic functionalities of the DYDAS user interface, and we will develop an exercise by performing an unsupervised classification approach based on the combination of Sentinel I and Sentinel II data. In particular, we will focus the attention over a specific area of interest represented here in this slide, and located in the southwest of Milan in the northern of Italy. We use two datasets acquired with the Sentinel satellites in May 2015, May 2020, respectively. And the exercise will use a combination of unsupervised clusterization with vegetation indexes approach. We will use, of course, Sentinel II data that for sure everybody well knows. Sentinel is a multispectral, Sentinel II is a multispectral imager radiometer, which acquire information over 30 spectral bands across the visible and the infrared portion of the electromagnetic spectrum, and with a spatial resolution which varies from 10 meter to 70 meter, depending on the particular wavelength of acquisition. We will use both near-infrared and optical wavelength to perform the exercise today. In particular, we will use also a combination of the radiances measured at visible and near-infrared spectrum wavelengths by computing two very well-known vegetation spectral indexes. The first one is the very well-known normalized difference vegetation indexes, while the second one is the normalized different water indexes that will be used to discriminate the presence of water in an unsupervised way over the acquired sheens. Together with the Sentinel II data, we will also exploit the scattering values as acquired by the Sentinel I sensor, which is a synthetic aperture radar instrument, which provides weather, day and night imagery of the Earth's surface. The instruments acquire information at C-band, and we will use both the VH and VB polarization images to better constrain the results of the unsupervised classificator, especially with respect the presence of homemade structures such as streets, roads, pardon, and buildings. Okay, so this is the introduction to the exercise that I will show you. And now we have to move to the DYDAS platform, which is of course needs to perform the login. Okay. Maybe. Okay, I have just to refresh. Oh, sorry. Okay. And then we can proceed with the login. If you receive this success message, this means that you have successfully logged in the platform. And this is the basic interface of the user experience platform of the DYDAS. Here we have different functionalities. Today, we will focus on the basic functionalities related to a project. Each user is enabled to implement one or more projects on the platform, and with within the My Project subfolder, you will see all the different projects that you are started. And here we have, of course, just one that is related to the demo of today. By pushing this button plus, you can create a new project. Otherwise, you have just to simple enter in the specific project for which you want to interact. And here you have other information collected in the details submenu. The contributors is just the list of the different contributors that can contribute to the project implementation. Here we have, of course, just demo users that is also the owner of the project, but you can add again by pushing this button additional users in order to collaborate in various ways to the project implementation. An important submenu is the datasets folder, which collect the datasets that you want to use in the application related to the present project. Again, by pushing this button, you can create a container for uploading or connected some data present in the data lake. Here, for sake of brevity, I have already produced the different containers for all the data that we will use today. We have two basic different kind of data set. The geospatial data set, which represent geospatial data without multi-temporal acquisition. And we have also geospatial time series, which are different type of container dedicated to contains the time series of geospatial data. Again, the interface is very simple since and intuitive, I hope, since you have here a different button that can be used to interact with the different data sets. In particular, you can download data once they are included in the container, or you can also upload data set from the user interface. Here we have already uploaded the input data from 2020, and now we can okay, yes, now we can test the possibility to upload just one data in order to be quick and proceed and go ahead with the rest of the demonstration. And we will now proceed to upload the Sentinel I and Sentinel II combination for 2015. Here we can proceed with pushing this button. And again, the interface is very simple, but of course you can provide some feedback about all the interaction that I'm showing you today. Here we have just to push the button, browse button, in order to search the folder where the data that we want to process is located. I have pre-elaborated the data by using a dedicated software in order to co-register Sentinel I and Sentinel II data, and producing a compressed folder that can be now uploaded on the system. Simple by pushing this button. Here you have to introduce some additional information. At present, we have the possibility to test these three different data formats, GeoTIFF, GRIB, and NetCDF, but in the next future, we will introduce a more extensive ensemble of data formats such as HDF and directly the ESA data formats, NASA data format, and so on. Okay, so here you have to know what is the data format of the data that you want to upload. And you can also shows an projection. So you have to know what is the projection of your data. And you have to choose also the modality for the inclusion of the data set in the container. Of course, in this case, we have to insert a new data in the container, which is empty at present. So we can proceed with upload button. Here you have a progress bar that show you the progress in the operation, and the pop-up message indicates that you have successfully uploaded the data set. Okay, then we will move to the models implementation and running. In the subfolder models, you have the possibility to interact with the notebook for directly implementing the code to be operated on the system. Also here we have already included two containers for the project models. We have a classification for 2015 and a classification model for 2020, which was already updated with the Python code for the model implementation. So before to move to the inspection of the Python code, in order also to show you some specific modalities of interacting with the data over the DYDAS data lakes, we can run the two models in order to produce the results that we will analyze as soon as they were completed. So once that you have included all the instruction required to run a model, you can proceed with the run button in order to operate your model. Here you have some basic choices related to the type of running that you want to operate. So now we can decide to run immediately our model, and then okay. You will see here the status of the operations as performed by the DYDAS interaction between the data lake and APC as implemented through the Python code. When the status is new, this means that you have introduced a new model in the container, and the platform are checking the correctness of the different operations that you are planning to be operated. And then once all the check was successfully completed, the status pass in to the accepted and then to running, and with the running this running message, the systems is indicated that your model is effectively running by exploiting the HPC feasibility of the DYDAS. Okay, now we can proceed to investigate better the structure of this simple model, also by taking into account the structure of this container, for which we have SRC main folder, under which you can introduce your model that can be composed by a main script, but also by connected functionalities that can be included. Okay, simple by clicking on the main.py, you will see the instruction brought on Python language for the different operation that can be produced by the running of this main. Of course, in this simple demonstration, we have maintained the complexity of the model very low by introducing only just a main script. For who are familiar with the Python scripting, you have to import the different functions that you want to use. And then here you have the main part, the most important part of the script, which is related to the framework of DYDAS and exploits dedicated functionalities which connects the Python scripting with the dedicated resources and facilities of the data lake and the HPC environment. In particular, you have to link the container of the data that we have seen before. Each container is characterized by a link. In the meantime, we have obtained the successful model runs, so we have a prompt to download the results for analyzing it. And here you have to introduce the link of the container that you can see directly by interacting with the container folder. These are two important operations which are related to the implementation of the dataset container over the HPC environment. So this part is related to the usage of the HPC in the framework of DYDAS and must be implemented by using this type of dedicated instructions. Then we have to use this library, which is the transformer libraries, which exploits all the functionalities of the geospatial data architecture and the ATL in order to transform the data to be used over the HPC. For using in a profitable way the HPC, regardless the type of data format, the DYDAS framework implement a transformation in an internal format that can be exploits the HPC computation. Then you can proceed with very standard operation and common operation in Python language. So you can use, for instance, a raster IO to open the data and then proceed with different operations in order to implement your model. We move on directly on the unsupervised classification approach that is here implemented by using an unsupervised simple model, which is the key means that is implemented by NumPy array, and then by using scikit-learn to implement the key means implementation. And the final part of the code is related to the computation of the NDVI and NDWI in order to find what are the labels individuated by the k-means can be classified as agriculture crops or as water in the acquired machine. And the last important part of the code is the opposite of the reading operation, so the movement of the data from the data lake to the HPC. And this
sorry, Matteo,
yeah,
you have 5 minutes.
Yes, we have completed this part, and then we can move directly to show you the final results. I want just to require the attention of our this inverse use of the transformer library in order to extract the data from the data lake and to put the data on the container for the data download. Okay, we can go back. Okay, previously I have already operated the model for the classification of 2020, so we can just go back to the data set and go to the container of the unsupervised classification results that can be at this stage downloaded, again showing a file format, and the same for the unsupervised classification results of the previous date. Here, this messages indicates that you are ready to download the datasets. Simple by clicking on this operation logs button and then moving to the download button here in order to to download the produced datasets. Here you can simple extract the two results that are provided as compressed formats, and here you have the results of your unsupervised classification that I have previously uploaded in an external interface such as a QGIS, but you can of course proceed to upload again. Okay, then we have just to copy the style, which I have chosen, and here we have the classified dataset. By using this simple approach, of course, we have some limitation in the results, since we have just classified all the green areas, such like agricultural crop, and all the man-made infrastructure as artificial, with an artificial label, artificial class label. But here you can see how by this approach you can obtain good results without employing more complex supervised technique. In particular, this is the results that we have downloaded directly from the platform, and that is related to the first date, while I'm using the preloaded results, and this is the results obtained for the 2020, and in particular you can see here as we have some differences, for instance in this part, related to the presence of a new man-made structure in the acquired scenes. Okay, this is the conclusion of this demonstrational example. I want just to again to show you the link. Is here to the surveys, and in particular, I invite everybody to complete this very simple survey by including your email in this form. In this way, you can be selected to participate as beta tester to the first release of the DYDAS platform in order to test the functionalities and to better understand how to use this framework for implementing model like this one, or also and especially model much more complex than the one that I have exposed today. So if you have any question, I'm able to answer now.